Welcome to the video. Here in this video I am discussing the KTU 2019 syllabus semester 3 engineering mathematics, that is partial differential equations and complex analysis. Here I am starting with the module 1, that is partial differential equations. This is a new topic for all of you. The partial differential equations are extremely important in both mathematics and physics. This video provides an introduction to some of the simplest and most important PDEs and their elementary things. We begin our study of partial differential equations with an introduction of some of the terminology associated with the topic. We all are familiar with what is an ordinary differential equation and how to solve different types of ordinary differential equations. Here in this module we are going to study what is partial differential equation and how to solve a partial differential equations. Partial differential equations are differ from ordinary differential equations in that the equation has a single dependent variable and more than one independent variable. We all study about functions, their characteristics in the previous semesters, but in previous semesters we deal with the functions of the form y equal to f of x, like that. That means one independent variable only. But practically if we study some quantities like area or volume or speed, etc., it depends more than one independent variables. So here for dealing this type of quantities we use the partial differential equations. So in this module we deal with the functions of many independent variables. Moving to the definition of partial derivative, let u equal to f of xy be a function of two independent variables x and y. That means here u is the dependent variable and x and y are the two independent variables. Then let's see how the partial derivative is defined. Then the partial derivatives of u with respect to x and y are defined as this one. It is read by dou u by dou x. Here we are not dealing with the total derivative because here there are more than one independent variable. So the partial derivative notation is dou u by dou x is equal to limit delta x tending to 0 f of x plus delta x comma y minus f of xy divided by delta x. This is the formal definition of partial derivative, which means in terms of limits. Similarly, dou u by dou y equal to limit delta y tending to 0 f of x comma y plus delta y minus f of xy divided by delta y. If there are two independent variables, then we got the partial derivatives as dou u by dou x and dou u by dou y. This is a formal definition of partial derivatives in terms of limits. Here the symbol for partial derivative is usually read as del or dou. It should not be written as delta. Delta, which means a change. The partial derivative notation is dou or del. That is dou u by dou x is called the partial derivative of u with respect to x. While finding dou u by dou x in problems, we treat the y as a constant term. Similarly, when you find dou u by dou y, which means the partial derivative of u with respect to y, here x is treated as a constant. Moving to the problems, find the first order partial derivatives of the function u equal to 3x square y plus 6xy square plus 7. Here u depends on x and y. So we want to find the partial derivatives with respect to u and with respect to y. Let's see the solution. Here u equal to 3x square y plus 3xy square plus 7. Then the first order partial derivative is dou u by dou x is equal to, while finding dou u by dou x, we treat the y as a constant term. So here 3x square y, 3 is a constant term and y is also considered as a constant term. So 3y remains a constant. The derivative of x square with respect to x is 2x. So the answer is 6xy plus. Next one, 6 is as constant and y square is treated as a constant. So 6y square is a constant. The derivative of x is 1. So the answer is 6 into 1 into y square plus derivative of 7. 7 is a constant term. So derivative of 7 is 0. So plus 0. So dou u by dou x is equal to 6xy plus 6y square. Similarly, dou u by dou y, while finding dou u by dou y, treat x as a constant term. So here 3x square is treated as a constant term. Then derivative of y with respect to y is 1. So 3x square into 1 plus 6x is treated as a constant. Then derivative of y square is 2y. So 6x into 2y plus derivative of 7 is 0. So the answer is 3x square plus 12xy. So this is the first order partial derivatives of u with respect to x and with respect to y. Okay, then moving to the second problem. Find the first order partial derivatives of z equal to x cube plus y cube minus 3axy. Let's see, here z equal to x cube plus y cube minus 3axy. Then the first order partial derivatives, here the variable is z and independent variables are x and y. So here dou z by dou x, this is the partial derivative, that is equal to with respect to x. So treat y as a constant. Derivative of x cube is 3x square plus derivative of y cube, y is a constant term. So derivative of a constant is 0. So 0 minus 3axy, derivative of 3axy, 3a and y is treated as a constant. Then derivative of x is 1. So dou z by dou x is equal to 3x square minus 3ay. Similarly, dou z by dou y, x cube is a constant, so derivative is 0. Y cube derivative is 3y square minus 3ax is considered as a constant term. Then derivative of y is 1. So the answer is 3y square minus 3ax. So these are the first order partial derivatives of z. Dou z by dou x and dou z by dou y. Next we are moving to the partial differential equation. Partial differential equation is a mathematical equation that involves two or more independent variables. That is an unknown function which depend on those variables and partial derivatives of the unknown functions with respect to the independent variable. That is a differential equation containing terms as partial derivatives is called a partial differential equation, which is shortly denoted by PDE. If you are given a differential equation, we can find its order. So here the order of a PDE is the order of the highest partial derivative involved in them. Okay, so a differential equation containing partial derivatives is called the partial differential equation, and order of the PDE is the order of the highest partial derivative. If z equal to f of xy, then we say that z is the dependent variable and x and y are the two independent variables. Okay, so z depends on x and y. Next we are moving to some examples. Here it is given that dou z by dou y plus x into dou z by dou x equal to x plus y. Here this equation contains some partial derivatives. Okay, so this is a PDE. Then let's see what is the order. Here the highest partial derivative is dou z by dou y and dou z by dou x, which means the power is 1, order is 1. So it is a PDE of order 1. Next one, dou square z by dou x dou y plus dou square z by dou y square equal to x. Here the equation contains some partial derivatives, so it is a PDE. Then what is the order? Highest partial derivative is dou square z. This is the highest order partial derivative. So its order is 2. So the first problem is a PDE of order 1 and the second one is a PDE of order 2. Next we are moving to some notations for first order partial derivatives and second order partial derivatives. The first order partial derivatives dou z by dou x is denoted by small letter p and dou z by dou y is denoted by small letter q. These are the first order partial derivatives. Then what are the second order partial derivatives? Dou square z by dou x square, which means dou by dou x of dou z by dou x. It is denoted by r. And dou square z by dou x dou y. It is denoted by s. And dou square z by dou y square is denoted by t. So r, s, t are the second order partial derivatives. So these are the notations for partial derivatives. P, Q, R, S, T. Next one problem. Find the first and second order partial derivatives of z equal to x cube plus y cube minus 3axy. This problem is discussed earlier. In that problem we discussed the first order partial derivatives. Okay. Here is z equal to x cube plus y cube minus 3axy. The first order partial derivatives are dou z by dou x. That is equal to 3x square minus 3ay. Then what is dou square z by dou x square? Which means dou by dou x of dou z by dou x. This is dou z by dou x. Here again differentiating with respect to x, we get the answer as 6x. Similarly, the first order partial derivative dou z by dou y equal to 3y square minus 3ax. Then what is dou square z by dou y square? That is dou by dou y of dou z by dou y. That is equal to 6y. Then dou square z by dou x dou y, which means dou by dou x of dou z by dou y. That is equal to minus 3a. Similarly, we can find dou square z divided by dou y dou x. That is dou by dou y of dou z by dou x. So dou z by dou x is 3x square minus 3ay. Again differentiating with respect to y, answer is minus 3a. For continuous functions, these two partial derivatives, that is dou square z by dou x dou y and dou square z by dou y dou x, are same. Give us the same answer. So here the function is a continuous function, which is a polynomial function. So for continuous functions, dou square z by dou x dou y and dou square z by dou y dou x will be same. Okay. So that's the first order and second order partial derivatives. This is the exercise problems. Evaluate the first order partial derivatives of the following functions.